Hello everyone, myself Srivalli, working as an assistant professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology. Today we are going to discuss about the problems on multinomial quotients and also how to expand this multinomial theorem. So first here, the first question is here, compute the following. So the question is here A. So how you can rewrite is 7, 2, 3, 2. So here, as we know that here, this is n factorial, this is n1, this is n2, n3. So from the multinomial theorem, we know that the formula is here n factorial by n1 factorial, n2 factorial, n3 factorial, so on up to nm factorial. And here x1 whole power n1, x2 whole power n2, so on here xm whole power nm. So now by applying this formula, you have to substitute these values in the given. So here n is equal to here 7 and here n1 is equal to 2, n2 is equal to 3, n3 is equal to 2. So now here if you equal these all n1 and n1 plus n2 plus 3, so you should get here again 7 value. That is nothing but here 2, 3, 2. So 2 to 4, 4 plus 3, 7, which is nothing but here, this is equal to 7 here. So now just substitute in the formula here, n factorial by, which is nothing but here, 7 factorial by, so 7 factorial by 2 factorial, 3 factorial into 2 factorial. So here if you observe, we don't have any coefficients here. So but directly you can take it as 1, 1, 1, 1. And you can substitute, you can give it here 7 factorial by, so 2 into 3 into 2 into 2. So now here 7 into 6 factorial. So 7 into 6 into 5 factorial. So here 2, 3, 2 into 2. So 3 2s are 6 and 2 will get cancelled. So you'll get 7 into 5 factorial by 4, which is nothing but you are going to get the answer here 210. So this is the answer you'll get for the first problem. Next, if you go to the second problem here, so here B bit is 8, 4, 2, 2, 0. So is equal to, here n is equal to 8, n1 is equal to 4, n2 is equal to 2, n3 is equal to 2, so n4 is equal to 0. So now if you substitute here 8 factorial by 4 factorial, 2 factorial, again 2 factorial, 0 factorial. So it is 0 factorial means 0 into 1 here. So you'll get 0 factorial and 1 only you'll have. So the answer you'll get here is 420. If you substitute, solve it. Now here 12, 5, 3, 2. So here the question here is n is equal to 12 factorial and here 5 factorial, 3 factorial, 2 factorial, again 2 factorial. So here you'll get the answer. If you simplify it, you can get the answer 163320. So in the same way, if you go for D bit here, 4, 1, 1, 1, 2. So which is nothing but here 4 factorial. So here the n1 value is what here? 1 factorial and this is 1 factorial and this is 2 factorial. So here you will get the answer. So 4 into 3 into 2 into 1, which is nothing but here 2 into 1. So the answer is here 12. So this is like how you need to solve it here. If the question is like compute the following, you have to consider this is the n value and these are n1, n2, n3 values and will not have any coefficients to write down here right side. So that is like you have to solve the problem. Next, we have find the quotients of a6 b cube in expansion of a plus b plus 2 whole power 12. So here, if you write the question here, you need to find out the coefficient of a power 6 b cube. In the coefficient of a plus b plus 2 whole power 12. Now here if you observe, m is equal to 12 and m1 is equal to 6, m2 is equal to 3 and we don't know m3. Why we need here m3 is, as we have 3 here, 3 places, but we don't know third variable value. So you need to find out here, as we know that m is equal to m1 plus m2 plus m3. So which is nothing but here m is equal to 12, m1 plus m2 means 6 plus 3 plus 9. So which is nothing but here m3. So m3 is equal to 12 minus 9 is 3. So here m is equal to 3. Now you have to find out the quotient of this a power 6 whole b power 3. So which is nothing but here 12 factorial by, as we know that here the formula is here. So here what is the question here? A plus b plus 2 whole power 12. So here you will get 12 factorial by. So next what are n1 here? 6 factorial into 3 factorial into 3 factorial into, so here 1 whole power 6. So this 1 is nothing but here what? A coefficient is 1. So here you can write it as here a power 6, b power 3 and we don't have here c, which is nothing but here 3 power 3. So which is nothing but here you will get 12 factorial by 6 factorial by 3 factorial into 3 factorial. So 3 3s are 9, 9 3s are 27 into a6b cube. So this 3, if you write 3 into 2 here, 3 9s are 27. So here you will get the answer here 12 factorial into 9. So here if you write here, so 3 3s are 9 you will get. So which is nothing but 12 factorial into 3 by 6 factorial into 2 factorial into 2 into 2, which is nothing but this is a power 6 b cube coefficient answer. So like this we need to solve the problem for the coefficient of multinomial theorem here. So we also have another problem here. Find the coefficient of x square y cube z power 5 in x plus y plus 3 whole power 10. So now here let us write down the given question here. So you need to find out here x square y cube z power 5. So the question is here x plus y plus 3 whole power 10. So now if you observe here 10 factorial. Why? Because here n is equal to 10. So n is equal to 10 here. m1, m2, m3 values are 2 power 2 factorial, 3 factorial into 5 factorial. So here as we have only here the coefficient of x square and y cube. So here you will get the answer. This is the answer. 10 factorial means 10 into 9 into 8 into 7 into 6 into 5 factorial. So 2 factorial into 3 factorial by 5 factorial. 5 will get cancelled. So even here if you observe 2 into 1, 10 into 9 into 8 into 7 into 6. So which is 2 into 3 into 2 into 1. So 3 2s are 6, 2 will get cancelled here. So even 2 4s are 8 and the leftover answer is 10 into 9 into 7. So whatever the answer you are getting 90 into 7 here. So which is nothing but here 630 you will get. So like this you have to find out the coefficient here in this third problem also. So next we also have here find out the coefficient of x power 5 y square z square in the expansion of x plus y plus z whole power 9. So here the given question is here x power 5 y square z square. So in the expansion of x plus y plus z whole power 9. So here if we observe, so n is equal to 9 here and this phi 2 are the n1 and n2 values here. Then here Compute the following means here you have to take 9 factorial by, so 5 factorial into 2 factorial into 2 factorial. So here next you will get x power 5, y square and even z square. So why? Because here all coefficients we have 1 only. So if it is 1, you will get as it is here. So this is the answer. If you simplify it here, 9 into 8 into 7 into 6 into 5 factorial by 5 factorial into 2 factorial into 2 factorial. So 5 factorial will get cancelled. So here if you take 2 into 1 and 2 into 1, so 2 4s are 8, 2 3s are 6. So here you will get 9 4s into 7 into 3. So this is the answer here. You can take 9 4s are here 36, 36 into 3 here, 3 6 are 18, 3 3s are 9. So 108 into 7. So here you will get 1250 answer. So this is the answer you will get, the coefficient. Next we have determine the coefficients of x, y, z power 2 in the expansion of 2x minus y minus z whole power 4. So here x, y, z square in the expansion of here 2x minus y minus z whole power 4. So here the coefficient of here you are going to find out x, y, z in the expansion of this 2x minus y minus z whole power 4. So now here n is equal to 4. And we know the formula here, x1 plus x2 plus x3 so on plus xm whole power n is equal to n factorial by n1 factorial, n2 factorial so on nm factorial. So here the coefficient here x1 whole power n1, x2 whole power n2, x3 whole power n3 so on xm whole power n1. So now if you take here, take n value is equal to 4 factorial now. So now x, y, z 1 factorial into 1 factorial into 2 factorial. Now here, so we need to take the coefficients here. So 1 is nothing but here 1 power 1. So here you will get x, and again 1 power 1, again you will get here y, and in z place you will get here. So here we have the coefficient here is 2 we have, no, so here 2 into 2x whole power 1 minus y whole power 1, and here minus z whole power 2 you will get. So now if you observe here, so here if you observe here 4 factorial by 1 factorial into 2 factorial. So now here, so here you will get 2 into x minus 2 x y z square. So 4 factorial by 2 will get cancelled. So here you will get minus 4 factorial, which is nothing but minus 24. So the coefficient of x, y, z square is minus 24. So this is like how you have to solve the problem for this coefficient of x, y, z square. So now next we have another question. So determine the coefficients of x square, y square, z cube. So in the expansion of 3x minus 2y minus 4z whole power 7. So here we have x square, y square, z cube. So 3x minus 2y minus 4z. So here as usual you have to take 7 factorial by 2 factorial into 2 factorial into 3 factorial. So now 3x. So 3x whole power square minus 2y whole power 2. So minus 4z whole power 3. So now here 7 factorial by 2 factorial, 2 factorial into 3 factorial. So now here 9 into 4, 4 4 is 16, 16 4 is 64 into x square. So y square z cube. So here the coefficient of x square y square z cube is 7 factorial by, so here 3 into 2, if you take 3 3s are 9, so 2 2s are 4, so and this 2 2 will get cancelled and this 2, so 2 3s are 2 2s are. So now if you observe here 7 factorial into 3 into 32 is the answer for coefficient of x square, y square and z cube. So next, so we have another problem also. This is the last problem. Determine the coefficients of here a square b cube c square d power 5 in the expansion of. So here a square b cube c square d power 5. Altogether here how many terms we have? 5 terms. So, but we have only 4 terms here, but in the question here 5 terms. So that is what here. In the expansion of a plus 2b plus 3c plus 2d plus 5 whole power 16. Now if you observe here, we know that n1 plus n2 plus n3 so on plus nm is equal to n. So now we have how many terms here? So we know that n1 is equal to 2, n2 is equal to 3, n3 is equal to 2, n4 is equal to 5, but we don't know n5. So why? Because we have n1, n2, n3, n4, n5. So but we have here only 4 terms, n5 is missing. Now but we know that here, so n1 plus n2 plus n3 plus n4 plus n5 is equal to n. So which is nothing but 2 plus 3 plus 2 plus 5 plus n5 is equal to n here. So now if we observe here, so 5 plus 5, 10, 12. So we know that n is n5, n is equal to 16 and this what we got here is 12. So here n5 is equal to 16 minus 12, which is nothing but 4. So as we got here 4, n5 term is 4. Then you can write it here 16 factorial. So here you can write it. So here we can write it here 16 factorial by 2 factorial into 3 factorial into 2 factorial into 5 factorial. So we have another term also here. So what is that here is 4 factorial into. Now here a power 2 b cube. So what is b cube here? We know that 2b whole cube and 3c whole square 2d whole power. So here 2d whole power, what is d value here? So 5 power 5, and here this is the coefficient you are going to see here. So 16 factorial by 2 factorial into 3 factorial into 2 factorial into 5 factorial into 4 factorial a square b cube 3c square, which is nothing but c square d power 5, and here you will get here 2 into, so 8 into 9 into 32. So coefficient of a square b cube c square d power 5 is 16 factorial, 2 factorial, 3 factorial, 2 factorial, 5, 4 factorial, 8 into 9 into 32. So this is the answer. So like this is like you need to find out how to find out the coefficients for the multinomial theorem. So what we have discussed today is few problems on how to solve the multinomial coefficients and also how to expand this multinomial theorem. So for this, by this we'll end the session. Thank you.